Hello guys, welcome to our channel. On this channel you have lectures on some A-level topics in maths, physics and further math. Okay, let's start. If we consider the collision of two spherical balls of masses m1 and m2 and speed before collision u1 and u2, the collision is along their lines of impact. Then during collision, if you assume that they are moving like this or anyhow, we must not know the direction. The momentum or the impulse on sphere 2 will be I, and the impulse on sphere 1 will be negative I. I because you have chosen our direction to be this is the direction. So impulse in this direction will be positive and impulse in this direction will be negative. Now, if the velocities after collision are v1 and v2 for spheres m1 and m2 respectively, then from the law of conservation of linear momentum, we state that the momentum before collision is equal to the momentum after collision. Therefore, m1 u1 plus m2 u2 must be equal to m1 v1 plus m2 v2. Call this equation 1. Now, from Newton's experimental law, v1 minus v2 is equal to e into u2 minus u1. Call this equation 2. This is Newton's experimental law. From these two equations, you can be able to calculate the velocity of v1 after collision and v2 after collision, because you have a system of two equations with two unknowns. Now, let's consider a case where sphere 2 is originally at rest, therefore u2 is equal to 0, and the two balls stick together after collision, and therefore v1 will be equal to v2, which is just v. If that is the case, the law of conservation of linear momentum will become m1 u1 equal to m1 plus m2 v, and from here the velocity will be m1 on m1 plus m2 u1. Clean and clear, I hope so. And here you can determine the kinetic energy before collision to be half m1 u1 squared. Since u2 is 0, therefore kinetic energy before collision of sphere 2 is 0, and the total kinetic energy is just that of sphere 1. And in the same way, the kinetic energy after collision will be a half m2 all over m1 plus m2, this is squared, m1 squared on squared. This is the kinetic energy after collision. Now, if the kinetic energy after collision is approximately equal to the kinetic energy before collision, then this is said to be an elastic collision. And if the kinetic energy after collision is different from the kinetic energy before collision, this is an inelastic collision. Now, if you consider a second case where sphere 2 is at rest, therefore u2 is equal to 0, but after collision, the two spheres do not stick together, thus u1 will be different from v2. In that case, the law of conservation of linear momentum becomes m1 u1 to be this, m2 v2. And Newton's experimental law will be v1 minus v2 to be equal to e u2. This is our equation 1. This is equation 2. From equation 2, v1 is v2 plus e u2. If we call this equation 3, then we substitute this in equation 1. We'll have m1 u1 to be m1 v2 plus m1 eu2 plus m2 v2. You can rearrange this to make v2 the subject of the equation. If you do that well, you have v2 to be m1 u1 minus m2 u1 e divided by m1 plus m2. Is that it? In a similar way, you can determine v1. We know that v1 is equal to v2 plus e u2. When you substitute that and simplify everything, you have v1 to be m1 u1 into 1 plus e divided by m1 plus m2. And we had v2 to be u1 into m1 minus m2 e divided by m1 plus m2. Now, you can be asked in a question, in a similar question to this second example, to give the direction of the velocities. That's the direction after collision. If you check here, this m1 minus m2e will give you the direction or the behavior of sphere 2 that was originally at rest. Since sphere 2 was originally at rest, if m1 minus m2 M2E is equal to 0. Therefore, sphere 2 will remain at rest. So you can assume that the force acquired by M2 by M1 during its motion was less than the inertia required for sphere 2. That means you can have a very big mass here, you have another small mass here. When you come and hit, you will not even feel the difference. This sphere 2 will not move. This one will just hit and come back. So you still have your sphere 1 here that will come back. But if M2 minus M1E is greater than 0, then this is the collision. You have something like this. Sphere 2 will move in this direction. In the positive, will continue in the same direction after collision. And if M1 minus M2E is less than 0, what will happen? I leave you this one to answer in the comments. I'll be waiting for your replies. If we consider a third case where the two spheres are originally in motion, that is, you have U1 and U2, and after collision now they move with velocities V1 and V2, then you have these two equations which you can solve simultaneously to have the values of V1 and V2. With that, with the values of V1 and V2, you can calculate the kinetic energy after collision, which is a half M1 V1 squared plus a half M2 V2 squared, and the kinetic energy before collision, a half M1 U1 squared plus a half M2 U2 squared. And from these two, you can determine whether the collision is elastic or inelastic. The kinetic energy after collision minus the kinetic energy before collision is approximately 0. This collision is elastic. And if the change in kinetic energy is different from 0, this is inelastic. Okay, thank you very much. That was all for today. Please like my video and subscribe to the channel. If you did not understand something, leave it in the comment and I will reply to you. Thanks.